Welcome to Understand the Math. In this video, we're going to learn about summation notation, also known as sigma notation. We'll start by going over what it is and look at some examples where we evaluate a sum, followed by examples where we'll learn how to write a sum using summation notation. Let's start by learning about summation notation. Summation notation, often called sigma notation, is just a shorthand way of writing the sum of the first n terms of a sequence using the Greek letter sigma, which stands for sum. We can write the sum of the first n terms of a sequence as the sum from I is equal to 1 to n of a sub I. I is called the index of summation. 1 is the lower limit of our summation. It doesn't always have to be 1. It can be 0, it can be 10, or any other number. And then n is called the upper limit of the summation. I'm going to now throw out one more piece of vocabulary to you. The sum of the terms in a finite or an infinite sequence is called a series. When we just list the terms, it's called a sequence, but when we add the terms, it's called a series. Let's now walk through some examples where we're going to evaluate a sum that is written in summation notation. In all these examples, we are going to find each sum. Let's look at our first example. To evaluate this sum, we're going to start by writing down all of the terms. We start with I is equal to 1, so we plug in that I is 1, so this is 1 squared. And because we have the sigma sign, that just means that we're going to be adding. For the next term, I is 2, so we have 2 squared. And then we add our third term, which is 3 squared. And then we're going all the way up to 4. So our last term is 4 squared. Now we just have to add this up. This is 1 plus 4 plus 9 plus 16. Let's see here. This is 5. And this is 25. So our sum is equal to 30. Let's now look at our second example. For this one, we are starting at 3 and going up to 5. So we'll start by writing down our first term. For our first term, k is 3, so this is 1/3. And then our next term, k is 4, so this is 1/4. And then our last term, k is 5, so this is 1/5. Now we have to add fractions. I know everybody doesn't love fractions. What we're going to do is we're going to get a common denominator. So we're going to take 3 times 4 times 5. Let's write that over here. 3 times 4 times 5. That's 3 times 20, which is 60. So that's our common denominator. And then 3 goes into 60 20 times. So we write down 20. And then 4 goes into 60 15 times. All you have to do is take 60 divided by 4 and you get 15. So we add 15. And then 5 goes into 60. Let's see what that is. 60 divided by 5 is 12. So we're going to add 12. This is equal to 20 plus 15 plus 12 is 27. We divide that by 60. So this gives us 47 divided by 60. And that's our answer. Let's now look at example 3. This one is different because it starts with a 0 and it also has a negative in it. Let's start by writing down our terms. Our first term is minus 2 to the 0. And then our second term is minus 2 to the 1. And then we have a minus 2 squared. We have a minus 2 cubed. And then our last one, j is 4. So we have a plus minus 2 to the 4th. Let's now write down what these are. Anything raised to the 0 power is 1. So we have a 1 minus 2. Minus 2 squared is going to be a plus 4. And then we have minus 2 cubed. That is minus 8. And then we have minus 2 to the 4th. It's going to be plus, and it's going to be 16. Let's now add these up. I'm going to add the positive ones and the negative ones. So we have 1 plus 4 plus 16. That's going to be 21. And then we're going to subtract off our negative terms, 2 and 8. So that's a minus 10. And that gives us an answer of 11. Let's now look at our next set of examples. We're now going to look at some examples where we're going to be given a sum and asked to write it using summation notation. Because these problems are a little bit harder, I've written down some steps that we can follow just to make it easier. The first step that we're going to do is we're going to set the first few terms equal to A1, A2, A3, A4, etc. And then what we're going to do is we're going to look for patterns. We're going to look for squares, cubes, alternating signs, and see if we can find the term a sub I that goes in the summation. Here's our first example. We're going to write the sum using summation or sigma notation. Let's write down our first couple of terms. A1 is the first term, which is 2. A2 is the second term, which is 4. And A3 is equal to 6. We want to see if we can find a pattern and relate each number to the index. A3 is equal to 6, and we can write 6 as 2 times 3. Now let's look at A2. We can write A2 as 2 times 2. Now we can kind of see a pattern. And we can write A1 as 2 times 1. Now we can see what a sub I is. We can say that a sub I is just going to be 2 times I. Now we can write down our sum using summation notation. It's equal to the sum from I goes from 1 all the way up to some number which we don't know yet, of a sub I, which is 2i. Now we have to find that top number. Our last term is 50, so let's set 50 equal to 2i. We'll solve for I, and we get I is 25. So we can come up to our summation, and we can write our top number as 25. Let's now look at our second example. We're going to start just like we did with our first example, and we're going to write down A1, A2, and then we'll see how many terms we need to write. A1 is equal to 2, A2 is equal to 5, A3 is equal to 10, and then let's write A4 is equal to 17. Let's start with A4 and see if we can write 17 in terms of 4. 4 squared is equal to 16, so we can think of 17 as 4 squared plus 1. We're just taking a guess, and let's see if this pattern holds. Let's look at A3. Can we write 10 in that same way? Can we write 10 as 3 squared plus 1? We can. Okay, this is great. The pattern's holding. Let's look at A2. That is equal to 2 squared plus 1. So we're good. That means that a sub I is equal to I squared plus 1. We can write our answer as the sum. I goes from 1 to a top number, which we haven't found yet, of a sub I, which is I squared plus 1. Now let's go ahead and let's find that top number. We are going to set I squared plus 1 equal to our last term, 65. Let's subtract 1, so I squared is 64. So we know that I is equal to 8. So I is going to go from 1 to 8. And that's our answer. Let's look at our third example. This example has numbers that alternate plus and minus. And we'll start just like we did before. Let's write down A1, A2, and all the other terms. A1 is equal to 1. A2 is minus 1/2. A3 is 1/3. And then A4 is minus 1/4. Notice that we are not given an ending number. So that means our summation is going to start at 1 and go to infinity. Let's go ahead and let's write that down. This is going to be equal to the sum. I goes from 1 to infinity. Now we just have to find a sub I. Let's look at our numbers and compare it to the index. A2 is minus 1/2. A3 is 1/3. And then A4 is minus 1/4. So our a sub I is equal to a number on top, either plus or minus 1, all divided by I. Now let's talk about the plus or minus 1. Our first term is positive, and then it becomes negative, and then it becomes positive again. The way that we're going to write that is we're going to write it as minus 1 to the n plus 1. You could also use n minus 1, but I think it's easier to use n plus 1. So a sub I is going to be minus 1 to the n plus 1, all divided by I. Now all we have to do is go up and put that in our summation. So we have the sum, I goes from 1 to infinity, of minus 1 to the n plus 1, all divided by I. And that's it. You now know all about summation notation, how to evaluate a sum written in summation notation, and also the harder part, how to write a sum in summation notation. You can do this, it just takes some practice.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.